Well, good afternoon, Professor. First, we are going to make the test of the turning radius and the Ackermann geometry. I'm going to go to a place when I have the enough space to make that test.
Opportunity, it necessarily calculate the center of the vehicle. For this, it necessarily learns the point on the front axle and on the rail axle. Calculate and in the middle in the wheel left. 10 is necessary calculate in the middle in the wheel right.
In this moment, I draw the line of the center of the wheel.
Yeah.
In this moment, we calculate the torque center.
The torque center is the middle in the lane.
The line is 5.26 meters. Well, the middle of this line is the turn center. So now we have the car turn off. So we're going to draw a point. Then I'm gonna drive the car. I'm gonna make I'm gonna make 180 degrees, and we are going to have a line from the wheel start and from the wheel ends. So we're going to have and calculate the turn center. Then we're going to calculate the center of the vehicle, and the line from the turn center to the center of the vehicle will be the radius. We're going to start with the first test.
Yeah, in this moment, let's start the test number 1.
From the turn center to the center of the car or the center of the vehicle, we have the radius. The radius is 3.64 meters. Start with the second test. In this, I'm going to try to maintain a velocity, and then I'm going to push the brake, and we're going to calculate the distance between from when I push the brake to when the car stops. Well, I'm going to start. First, I'm going to drive.
This is the vehicle.
Good afternoon, teacher. In this opportunity, I explained about the Ackermann steering geometry calculation. It's necessary to evaluate different parameters for this use this format. In the next part, we can do the group use or do learn the cards for evaluate different parameters. Using length the measures and wheels the car parking, we measure the length on the wheels, and also calculate the position center of the vehicle. For this, is the length. The length or the length is 2000 and 4 and 5 and 50 and 50 and 14 mm. And the next part is 150 50,000. In the next part is when the group evaluates the center of the center of the vehicle, the points from the center of the vehicle. For this starts we tour the cars and 118 radius, and marking the cars on the left and the tour and the diameter. And this lane was down from the initial real wheel and position and the final real wheel position. And we made of these lanes in the was in the tour center in the lane the things of the center of the vehicle and the tour center and the touring radius. And finally, the radio is 3000 and 50 and 54 mm. And in this part, in the final part, is change different values or characteristic of the formulas. Is in the final is these results, and the wheel from the right is the same. The angle of the wheel on the right is the same for the 13.053, and the next part on the wheels on the left is the same for the 41.30 3012. Is this the result for the group? Thank you.
Hi, Professor. Engineer Alejandro Montes. My name is Enzo Sarabia Montes. I talk about in this opportunity our resistance for test number 3. First, I talk about the rolling resistance. This is the equation. This is the all data necessary for test number 3. The mass of the vehicle, coefficients, mass Zavaleta, mass of Daga, and gravity. First, it's necessary to calculate the total weight with this equation, mass of the vehicle for gravity and the mass of my friend. This is the result for total weight. Yeah, but finally replace in this equation, and this is the result. No, this is the rolling resistance. Then it's necessary to calculate aerodynamic resistance. This is the equation. Yeah. This is the all data. Yeah. The equations, the constants, height of the vehicle, weight of the vehicle, what's the dimension, what is the dimension, and in this equation only replace the values, and this is the result. But for aerodynamic resistance, calculate with the velocity is 20 kilometers per hour. Only replace in this equation all the values, and this is the result. Yeah, aerodynamic resistance. Yeah, and finally I calculate inertial resistance. This is the equation. The values, initial velocity and final velocity is necessary the mass of the vehicle, and the other values I calculate the same of the when the velocity is at 20 kilometers per hour. I replace in with the equation, and this is the result. Thank you.
Continuing with the video, I speak the calculate total resistance. For the calculate total resistance, we showed add rolling resistance plus aerodynamic resistance plus inertial resistance. The
Total resistance for my case is 4682.15 kilogram force. Continues. Calculate the deceleration. Deceleration is said force divided mass. The force is said total resistance. The mass is the mass of vehicle plus mass Zavaleta plus mass Daga. The acceleration is said 2.95 meters between second 2. Calculate the shopping distance and time to stop. For the calculate the stopping distance, replace the deceleration in this equation. Variant the velocity, the initial velocity. Change the value in the equation. I obtained the shopping distance for the initial velocity. For example, 20 km/h is shopping distance 5.23 meters. For the 35 initial velocity, stopping distance is 16.22 meters. For the calculate the time to stop, and we should replace the acceleration in this equation and initial velocity. For the 20 km/h is 1.88 seconds. For the 35 km/h is 30.2096 seconds.